Good morning. Is everybody ready for the last lesson of the year, lesson 119? I told you yesterday we were going to be learning the quadratic formula, which is yet another method for us to solve quadratic equations. Remember, quadratic equations are equations that their highest exponent is a 2. So the standard form for a quadratic equation is ax squared plus bx plus c equals 0. All right? Now what we're going to do is we're going to use the completing the square method, and we're going to develop the quadratic formula. You don't have to do this again. You'll do it a lot next year in Algebra 2, but this year you're not going to have to repeat this. But I want you to see where it comes from so you don't think it's just some magic formula that someone dreamed up. So in order to do this, we have the problem in descending order already. We're going to, we need to make sure that we isolate the constant. So we're going to subtract c from both sides. So ax squared plus bx equals minus c. And then we didn't have this problem because we didn't have any problems that had a number in front of the x squared except for a 1. But in order to complete the square, the number in front of the x squared, or the coefficient of the x squared, has to be 1. In this case, it's not. So in order to get rid of that a, we have to divide everything by a. Okay, so here it cancels, and what we have left is x squared plus b over ax equals minus c over a. Process is the same. Take the middle coefficient, which in this case is b over a, multiply it times 1/2. So that's b over 2a. Do you remember what we do with that? Okay, we square it, which will be b squared over 4a squared, and we add that to both sides of the equation. So plus b squared over 4a squared plus b squared over 4a squared. And now we completed the square. This guy right here is a perfect square. So now we write it in factored form. Okay, remember the square root of this goes here. This sign goes right here. And the square root of this term goes here. So that would be b over 2a. And over here we get a common denominator, which is 4a squared. So this fraction right here is missing a 4 and an a. So we multiply it times the c, and that's minus 4ac. Plus, this already has 4a squared, so we just bring down the b squared. And I'm going to rewrite that because I really don't like that negative 4ac in front. Okay, what do we do next? How do we get rid of this square right here? Okay, we take the square root of both sides. So doing that gives us x plus b over 2a equals, remember when we take the square root of this other side, we have to put plus or minus because that's going to be a number. So plus or minus the square root of b squared minus 4ac. And you notice I didn't put the square root all the way down to the bottom of the fraction. Why did I not do that? Remember what we did on those other problems when there was a perfect square in the denominator? We just took it out and took the square root of it. So what's the square root of 4a squared? It's 2a. All right? And nicely enough, that's a common denominator, isn't it? So when we subtract this from both sides, we'll have a common denominator already. So x will be equal to minus b plus or minus the square root of b squared minus 4ac, and because it was a common denominator, we just write it over the 2a. And that, guys, is the quadratic formula. Okay? And that's where it comes from, so you don't think that someone just magically dreamed it up. They didn't. Okay, so now you're not going to be doing this, deriving it. You're going to be using it. So turn to page 502. Example 119.1. It says, use the quadratic formula to solve. So the first thing I want you to do is I want you writing that quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Why would that be so important to me for you to write it every time you have one of these problems? It's because repetition will help you remember it, okay? Next year when you derive it about 50 times, you'll never forget it again. But for now, I want you writing it every time you have one of these problems. So now remember, we go back to this, the standard form for a quadratic equation. A is the number that's in front of the x squared. B is the number in front of the x, and C is the constant without an x. So that's how we know which numbers to plug into the formula. So the first example says, solve this. 3x squared plus 2x minus 7 equals 0. So I want you to write a equals, b equals, and c equals. So remember, a is the number in front of the x squared, so a is 3. B is the number in front of the x, so b is 2. And c is the constant without an x. So what is this constant right here? It's negative 7. The sign in front of it goes with it. And that's true for if it was negative 3 in front of the x squared, it would be negative 3. If this was negative 2x, this would be negative 2. This is negative 7, so c is negative 7. So now what I'm going to do is I'm going to plug those values in to this equation right here. So x will be equal to minus b is 2. So minus 2 plus or minus the square root of 2 squared minus 4 times a is 3 times c is negative 7. All of that's over 2 times a is 3. I'll let you look at that for just a second. So in order to solve for x, really all we have to do now is simplify. So x will be equal to minus 2 plus or minus, and don't try to do too much at once. 2 squared is 4. And then this is this times this times this. So we have two negatives, which makes this a positive. And 12 times 7 is 84. All of that's over 6. So then we have x equals minus 2 plus or minus the square root of 88 over 6. You know, what's wrong with that? We can't leave it in that form because there's a perfect square that divides into 88. We can rewrite square root of 88 as what? 4 times 22. And why did I pick that? Because I know the square root of 4. So this will then become x equals minus 2 plus or minus the square root of 4 comes out in front, so that's a 2, and we leave the 22 underneath. Okay, so now do you think we're okay with that? No. In this case, I've been telling you, if you can factor a number out of the entire numerator that will cancel with the denominator, then you need to do it. Otherwise, it won't cancel. Well, in this case, we can divide both of these numbers by 2, can't we? So if we factor out a 2, negative 2 divided by 2 is negative 1, plus or minus 2 divided by 2 just cancels. So we have the square root of 22, and that's over 6. So now can you see how this will cancel? Because I have it written as a product, I can now take the 2 into the 6 3 times so that the answer will be minus 1 plus or minus the square root of 22 over 3. And that's two answers. Remember, that's minus 1 plus square root of 22 over 3 and minus 1 minus square root of 22 over 3. All right, a couple more of these. 119.2. Use the quadratic formula to determine the roots. That's another way of saying solve it. So it's written like this. I have to put it in standard form, guys. You cannot use the quadratic formula if your quadratic equation is not in standard form. And I want my x squared to be positive. So I'm going to go to the left. So in other words, I'm going to add x squared and subtract x. Add x squared and subtract x. So we'll have x squared minus x minus 6 equals 0. Okay, so A equals, if there's not a number in front of it, it's understood to be a 1. B equals, there's no number in front of it, but it has a negative sign, right? So that's going to be negative 1. And C is negative 6. So here's my formula. X equals minus B plus or minus square root of B squared minus 4AC, all of that over 2A. So plug your numbers in. X equals minus a minus 1. Remember, there's a minus right here in the formula, and your B is negative. So that's minus a minus 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 6. All of that's over 2 times A, or 2 times 1. Okay, so very carefully, negative times negative is positive 1. This will be 1, negative makes it positive 24 over 2. And then we have x equals 1 plus or minus the square root of 25 over 2. Well, what is the square root of 25? It's 5, so we simplify it. It'd be 1 plus or minus 5 over 2. Now, do you think you leave it like that? You leave it like that if you want to lose some points. You can finish this. One of the answers is x equals 1 plus 5 over 2, and the other answer is 1 minus 5 over 2. So 1 plus 5 is 6 divided by 2 is 3. 1 minus 5 is negative 4 over 2, which would be negative 2. So there are your two solutions to this one. If you can take the square root of it, you need to go ahead and do that and simplify the fraction. If it doesn't simplify like the last one didn't, then you leave it in radical form. All right, let's do one more. On page 503, 119.3, use the quadratic formula to find the values of x that satisfy the equation. All of these mean the same thing. Use the quadratic formula to solve it. I need this in standard form again, so I'm going to do this. I'm going to add x squared and subtract 7. So I'll have x squared minus x minus 7 equals 0, which means A is 1, B is negative 1, and C is negative 7. My formula, x equals minus b plus or minus square root of b squared minus 4ac, all of that over 2a, and here we go. Start plugging and chugging. So x equals minus a minus 1. Remember, your b is negative 1, plus or minus the square root of negative 1, and I put that in parentheses so I don't forget that when it's squared it's going to become positive. Minus 4 times a is 1 times c is negative 7 divided by 2 times 1. All right, so x equals 1 plus or minus the square root of 1 plus 28 over 2. So x equals 1 plus or minus the square root of 29 over 2. Square root of 29 won't simplify. There's nothing I can factor out of the numerator. So this is in simplest form. All right, Thank you, guys. You're all done with the book.